Good morning, everyone. My name is Mazharul Islam. Presently, I am working as an assistant professor in the Department of Computer Science, USTM. Today, I will be talking about an essential component of networking, that is transmission media. In simple terms, transmission media refers to the pathways that carry data from one device to another. This can be physical cables like fiber optics or wireless signals like radio waves. Without transmission media, communication over networks would not be possible. In this presentation, we'll explore the different types of transmission media, their advantages, and how they impact modern communication. Now, let's see the definition of transmission media. So, transmission media is a communication channel that carries the information from the sender to the receiver. Data is transmitted through the electromagnetic signals. The main functionality of transmission media is to carry the information in the form of bits through LAN. Here, LAN stands for local area network. It is a physical path between transmitter and receiver in data communication. In a chopper-based network, the bits in the form of electrical signals, and in a fiber-based network, the bits in the form of light pulses. In the vessel phase, transmission media supports the layer 1. Therefore, it is considered to be as layer 1 component. The electrical signals can be sent through the copper wire, fiber optics, atmosphere, water, and vacuum. The characteristics and quality of data transmission are determined by the characteristics of medium and signal. Transmission media is of two types, that is wired media and wireless media. In wired media, medium characteristics are more important, whereas in wireless media, signal characteristics are more important. Different transmission media have different properties such as bandwidth, delay, cost, and ease of installation and maintenance. The transmission media is available in the lowest layer of the Weiser reference model, that is physical layer. Now let's see the factors that need to be considered for designing the transmission media. So first one is bandwidth. All the factors are remaining constant here. The greater the bandwidth of a medium, the higher the data transmission rate of a signal. Secondly, transmission impairment. When the received signal is not identical to the transmitted one, due to transmission impairment, the quality of the signal will get destroyed due to transmission impairment. Thirdly, interference. An interference is defined as the process of disrupting a signal when it travels over a communication medium on the addition of some unwanted signal. So here are the categories of transmission media. Basically, it can be divided into two parts. First one is guided media and second one is unguided media. Further, the guided media can be classified into coaxial cable, fiber optics cable, and two-state media. And unguided media can be categorized as radio waves, microwaves, and infrared waves. Furthermore, coaxial cable can be further divided into baseband and broadband signals, whereas two-state media can be divided into unshielded and shielded medium. Now we'll see the classification of transmission media. So let's see first guided transmission media. So it is defined as the physical medium through which the signal are transmitted. It is also known as bounded media. Secondly, it provides a conduit from one device to another, include two-state pair cable, coaxial cable, and fiber optic cable. A signal traveling along any of this media is directed and contained by the physical limits of that medium. Twisted pair and coaxial cable use metallic conductors like copper wire that accept and transport signals in the form of electrical current. Optical fiber is a cable that accepts and transports signal in the form of light. Now let's see twisted pair cable. Twisted pair is a physical media made up of the pair of cables twisted with each other. A twisted pair cable is cheap as compared to other transmission media. Installation of the twisted pair cable is easy and it is lightweight cable. The frequency range of twisted pair cable is from 0 to 3.5 kilohertz. A twisted pair consists of two insulated copper wire arranged in the regular spiral pattern. The degree of reduction in noise interference is determined by the number of turns per foot. Increasing the number of turns per foot decrease noise interference. Here you can see the diagram. This is the jacket portion, and these are the twisted pair, and these endpoints are called bare wire. Now let's see the types of twisted pair cable. So twisted pair cable can be divided into two types. First one is called unshielded twisted pair, and second one is called shielded twisted pair. Now let's see unshielded twisted pair. So an unshielded twisted pair is widely used in telecommunication. Following are the categories of the unshielded twisted pair cable. So category 1 include telephone lines that have low speed data. Category 2 can support up to 4 Mbps speed. Category 3 can support up to 16 Mbps speed. And category 4 can support up to 20 Mbps speed. Therefore, it can be used for long distance communication. And category 5 can support up to 200 Mbps speed. So it is very speed category. So advantages of this category are, first one is it is cheap and installation of the unshielded twisted pair is easy. Furthermore, it can be used for high speed LAN. And the disadvantage is this cable can only be used for shorter distance because of attenuation. Now let's see shielded twisted pair. So a shielded twisted pair is a cable that contains the mesh surrounding the wire that allows the higher transmission rate. Characteristics of shielded twisted pair are as follows. The cost of the shielded twisted pair cable is not very high and not very low. And installation of STP is easy. It has higher capacity as compared to unshielded twisted pair cable. It has a higher attenuation. It is shielded that provides the higher data transmission rate. The disadvantages include, firstly, it is more expensive as compared to UTP and coaxial cable. Secondly, it has a higher attenuation rate. Now let's see the coaxial cable. So coaxial cable is very commonly used transmission media. For example, TV wire is usually a coaxial cable. The name of the cable is coaxial as it contains two conductors parallel to each other. It has a higher frequency as compared to twisted pair cable. The inner conductor of the coaxial cable is made up of copper, and the outer conductor is made up of copper mesh. The middle core is made up of non-conductive cover that separates the inner conductor from the outer conductor. The middle core is responsible for the data transfer transferring, whereas the copper mesh prevents from the EMI, that is electromagnetic interference. So here you can see the diagram of coaxial cable. Again, this portion is called jacket, and these are called shields. And this portion is the insulator part, and this portion is called center conductor. Coaxial cable is of two types. First one is called baseband transmission. So it is defined as the process of transmitting a single signal at high speed. And secondly, broadband transmission, and it is defined as the process of transmitting multiple signals simultaneously. So here are the advantages of coaxial cable. Firstly, the data can be transmitted at high speed. It has better shielding as compared to twisted pair cable. It provides higher bandwidth. The disadvantages of coaxial cable are it is more expensive as compared to twisted pair cable. If any fault occurs in the cable, causes the failure in the entire network. Now we will see the fiber optic cable. So fiber optic cable is a cable that uses electrical signal for communication. Fiber optic is a cable that holds the optical fibers coated in plastic that are used to send the data by pulses of light. The plastic coating protects the optical fiber from heat, cold, electromagnetic interference from other types of wiring. Fiber optics provide faster data transmission than copper wires. This is the diagrammatic representation of fiber optic cable. So as you can see, again, this portion is called jacket, and next part is called cladding, and the third part is called core. And this is basically side view of the fiber optic cable. So here we will discuss the basic elements of fiber optic cable. So first one is called core. The optical fiber consists of a narrow stand of glass or plastic known as a core. A core is a light transmission area of the fiber. The more the area of the core, the more light will be transmitted into the fiber. Second one is called cladding. So here, the concentric layer of glass is known as cladding. The main functionality of the cladding is to provide the lower refractive index at the core interfaces as to cause the reflection within the core so that the light waves are transmitted to the fiber. And the third one is called jacket. The protective coating consisting of plastic is known as a jacket. The main purpose of a jacket is to preserve the fiber strength, absorb shock, and extra protection. So following are the advantages of fiber optic cable over copper. So first one is called greater bandwidth. Here, the fiber optic cable provides more bandwidth as compared to copper. Therefore, the fiber optic carries more data as compared to copper cable. Secondly, faster speed. Fiber optic cable carries the data in the form of light. This allows the fiber optic cable to carry the signals at a higher speed. Thirdly, longer distances. The fiber optic cable carries the data at a longer distance as compared to copper cable. Fourth one is better reliability. The fiber optic cable is more reliable than the copper cable as it is immune to any temperature changes, while it can cause obstruct in the connectivity of copper cable. The last one is thinner and sturdier. Fiber optic cable is thinner and lighter in weight, so it can withstand more pull pressure than copper cable. Now we'll discuss unguided transmission media. An unguided transmission media transmits the electromagnetic waves without using any physical medium. Therefore, it is also known as wireless transmission. In unguided media, air is media through which the electromagnetic energy can flow easily. Unguided transmission media is broadly classified into three categories. First one is called radio waves. So here are the some points regarding radio waves. So first one is radio waves are the electromagnetic waves that are transmitted in all the directions of free space. Radio waves are omnidirectional. That is, the signals are propagated in all the directions. The range in frequencies of radio wave is from 3 kHz to 1 kHz. In the case of radio waves, the sending and receiving antenna are not aligned. That is, the wave sent by the sending antenna can be received by any receiving antennas. An example of radio wave is FM radio. And here FM stands for frequency modulation. So here is the graphical representation of ground wave of Earth surface, as you can see. So we'll move to the next slide. So now we'll see the application of radio waves. Firstly, a radio wave is useful for multicasting when there is one sender and many receiver. Secondly, an FM radio, television, cordless phones are example of a radio wave. Advantages of radio transmission are, firstly, radio transmission is mainly used for wide area networks and mobile cellular phones. Secondly, radio waves cover a large area and then can penetrate the walls. Thirdly, radio transmission provides a higher transmission rate. Now we'll discuss microwaves. So microwaves are of two types. First one is terrestrial microwave and second one is satellite microwave communication. Now we'll see terrestrial microwave transmission. Here, transmission is a technology that transmits the focused beam of a radio signal from one ground-based microwave transmission antenna to another. Microwaves are the electromagnetic waves having the frequency in the range of 1 GHz to 1000 GHz. Microwaves are unidirectional as the sending and receiving antenna is to be aligned. That is, the waves sent by the sending antenna are narrowly focused. In this case, antennas are mounted on the tower to send a beam to another antenna which is kilometer away. It works on the line of sight transmission. That is, the antennas mounted on the towers are the direct side of each other. So characteristic of microwave are frequency range. So the frequency range of terrestrial microwave is from 46 GHz to 21 to 23 GHz. Next, we will see bandwidth. So in microwave, supports the bandwidth from 1 to 10 Mbps. Microwave are generally inexpensive for short distances. Again, in long distance, it is expensive as it requires a higher tower for a longer distance. In case of attenuation, it is affected by environmental conditions and antenna size. So now we'll see advantages of microwave. So advantages of microwave are microwave transmission is cheaper than using cable. It is free from land acquisition as it does not require any land for the installation of cables. Thirdly, microwave transmission provides an easy communication in terrains as the installation of cable in terrain is quite a difficult task. Communication over oceans can be achieved by using microwave transmission. Now we'll see disadvantages of microwave transmission. So disadvantages of microwave transmission are as follows. Firstly, eavesdropping. And eavesdropping creates insecure communication. Any malicious users can catch the signal in the air by using its own antenna. Secondly, out of phase signal. A signal can be moved out of phase by using microwave transmission. Thirdly, weather condition. A microwave transmission is susceptible to weather condition. This means that any environmental change such as rain, wind can distort the signal. Third one is bandwidth limited. Allocation of bandwidth is limited here. That is in case of microwave transmission. Now also satellite microwave communication. A satellite is a physical object that revolves around the Earth at a known height. Satellite communication is more reliable nowadays as it offers more flexibility than cable and fiber optic systems. We can communicate with any point on the globe by using satellite communication. Here are the advantages of satellite microwave communication. We'll see one by one. First one is the coverage area of a satellite microwave is more than the terrestrial microwave. Secondly, the transmission cost of a satellite is independent of the distance from the center of the coverage area. Thirdly, satellite communication is used in mobile and wireless communication applications. Fourthly, it is easy to install. And lastly, it is used in a wide variety of applications such as weather forecasting, radio, TV signal broadcasting, and mobile communication, etc. So here are the disadvantages of satellite microwave communication. Firstly, satellite designing and development requires more time and higher cost. Secondly, the satellite needs to be monitored and controlled on regular periods so that it remains in orbit. And thirdly, the life of the satellite is about 12 to 15 years. Due to this reason, another launch of the satellite has to be planned before it becomes non-functional. Now we'll see infrared signal. So an infrared transmission is a wireless technology used for communication over short ranges. The frequency of the infrared in the range from 300 gigahertz to 400 terahertz. It is used for short range communication such as data transfer between two cell phones, TV remote operations, data transfer between a computer and cell phone, research in the same closed area. So here are the characteristics of infrared. First point is it supports high bandwidth and hence the data rate will be very high. Second one is infrared waves cannot penetrate the walls. Therefore, infrared communication in one room cannot be interrupted by the nearby rooms. Thirdly, an infrared communication provides better security with minimum interference. And fourthly, infrared communication is unreliable outside the building because the sun rays will interfere with the infrared waves. Now we'll see switching technique. So when a user accesses the internet or another computer network outside the immediate location, messages are sent through the network of transmission media. This technique of transferring the information from one computer network to another computer is known as switching. Switching is a computer network is achieved by using switches. A switch is a small hardware device which is used to join multiple computers together with one local area network. Third point is network switches operate at layer 2, that is data link layer in the OSI model. Fourth point is switching is a transparent to the user and does not require any configuration in the home network. Switches are used to forward the packet based on MAC address. A switch is used to transfer the data only to the device that has been addressed. It verifies the destination address to route the packet appropriately. It is operated in full duplex mode. Packet collision is minimum as it directly communicates between source and destination. And lastly, it does not broadcast the messages as it works with limited bandwidth. Switching concepts is developed because of the following reasons. So first one is bandwidth. Here, it is defined as the maximum transfer rate of a cable. It is very critical and expensive resource. Therefore, switching techniques are used for the effective utilization of the bandwidth of a network. Second one is collision. Collision is the effect that occurs when more than one device transmits the message over the same physical media and they collide with each other. To overcome this problem, switching technique is implemented so that packets do not collide with each other. Advantages of switching technique are, first point is, switch increases the bandwidth of the network. Second point is, it reduces the workload on individual PCs as it sends the information to only their device which has been addressed. Thirdly, it increases the overall performance of a network by reducing the traffic on the network. And the fourth one is there will be less frame collision as switch creates the collision domain for each connection. So these advantages of switching techniques are, firstly, a switch is more expensive than network bridges. Secondly, a switch cannot determine the network connectivity issue easily. And thirdly, proper designing and configuration of the switch are required to handle multicast packets. Now we'll discuss different switching modes. So the layer 2 switches are used for transmitting the data on the data link layer, and it also performs error checking on transmitted and received frames. The layer 2 switches forward the package with the help of MAC address. Different modes are used for forwarding the packets known as switching modes. In switching mode, different parts of a frame are recognized. The frame consists of several parts such as preamble, destination MAC address, source MAC address, user data, etc. So here you can see different switching modes. Here, this is frame header, then network header, next transport header, and this portion is called data, and this portion called FCS. Frame header can be divided into preamble, destination MAC address, source MAC address, and ether type. And FCS can also be categorized as checksum based on CRC. Now we'll discuss the type of switching mode. So there are basically three types of switching modes. First one is called store and forward. Second one is called cut through, and third one is called fragment free. So firstly, we will see store and forward technique. So here, as you can see, This portion is called preamble, and after preamble, destination MAC address is there, and next source MAC address is there, and next type is ether type, and this is our data, and this is called FCFs. So all these addresses will be stored and forwarded to the FCS, as you can see in the diagram. Store and forward is a technique in which intermediate nodes store the received frame and then check the errors before forwarding the package to the next node. The layer 2 switch waits until the entire frame has received. On receiving the entire frame, switch store the frame into the switch buffer memory. This process is known as storing the frame. When the frame is stored, then the frame is checked for the errors. If any error found, the message is discarded. Otherwise, the message is forwarded to the next node. This process is known as forwarding the frame. CRC means cyclic redundancy check. It is a technique which is implemented that uses a number of bits to check for the errors on the received frame. The store and forward technique ensures a high level of security as the destination network will not be affected by the corrupted frames. Store and forward switches are highly reliable as it does not forward the collided frames. Here is the diagram of cut-through switching. So cut-through switching is a technique in which the switch forward the packets after the destination address has been identified without waiting for the entire frame to be received. Secondly, once the frame is received, it checks the first 6 bytes of the frame following the preamble. The switch checks the destination in the switching table to determine the outgoing interface port and forwards the frame to the destination. It has low latency rate as the switch does not wait for the entire frame to be received before sending packets to the destination. It has no error checking technique. Therefore, the errors can be sent with or without errors to the receiver. A cut-through switching technique has a low wait time as it forwards the packets as soon as it identifies the destination of MAC address. In this technique, collision is not detected if frames have collided will also be forwarded. In large networks, there can be multiple paths from sender to receiver. The switching technique will decide the best route for data transmission. Switching technique is used to connect the system for making one-to-one communication. So as you see in the diagram, switching technique can be categorized as circuit switching, message switching, and packet switching. Circuit switching can also be categorized in 2 parts. First one is called space division switches, and second one is called time division switches. And packet switching is further classified into datagram approach and virtual circuit approach. Again, virtual circuit approach can be further divided into switched virtual circuit SBS and permanent virtual circuit that is called PVC. Now we'll see circuit switching technique. So circuit switching is a switching technique that establishes a dedicated path between sender and receiver. In the circuit switching technique, once the connection is established, then the dedicated path will remain to exist until the connection is terminated. Circuit switching is a network operates in a similar way as the telephone works. A complete end-to-end path must exist before the communications take place. In case of circuit switching technique, When any user wants to send the data, voice, video, a request signal is sent to the receiver, then the receiver sends back the acknowledgement to ensure the availability of the dedicated path. Just wait. Okay. So dedicated path. After receiving the acknowledgement, dedicated path transfer the data. In circuit switching, it is used in public telephone network. It is used for voice transmission. Lastly, fixed data can be transferred at a time in circuit switching technique. So communication through circuit switching has three phases. First one is called circuit establishment, then data transfer, and then circuit disconnect. So as you can see in the diagram, this is node A and this is node B. If node A wants to send a message to node B, firstly, it establishes the circuit. Then secondly, it transfers the data, and after transferring the data, the circuit will be disconnected. So advantages of circuit switching is, in the case of the circuit switching technique, the communication channel is dedicated and it has a fixed bandwidth. So there are some disadvantages also. So the disadvantages of circuit switching are, first one is, once the dedicated path is established, the only delay occurs in the speed of data transmission. Secondly, it takes a long time to establish a connection, approx 10 seconds, during which no data can be transmitted. Thirdly, it is more expensive than other switching technique as a dedicated path is required for each connection. Fourthly, it is inefficient to use because once the path is established and no data is transferred, then the capacity of the path is wasted. In this case, the connection is dedicated, therefore no other data can be transferred even if the channel is free. Now we'll see message switching technique. Message switching is a switching technique in which a message is transferred as a complete unit and routed through intermediate nodes at which it is stored and forwarded. In message switching technique, there is no establishment of a dedicated path between the sender and the receiver. The destination address is appended to the messages. Message switching provides a dynamic routing as the message is routed through the intermediate nodes based on the information available in the message. Message switches are programmed in such a way so that they can provide the most efficient routes. Each and every node stores the entire message and then forward it to the next node. This type of network is known as store and forward network. Furthermore, message switching treats each message as an independent entity. So, thank you everyone. We'll see the next topic in our next class. So, thank you very much. Thank you.